equal to, guys, this is going to have 3 pieces. And it looks like this. And since we're here, I'm try to use different colors here for the pieces. The next one looks like this. And the third one looks like this. Mr. Park, you think the recording will be good?
Yeah, it's working right now.
Okay, guys, those 3 pieces. And we'll do a graph. Now, please, Tim, remind me, because it's been quite some time since I've done these. Did we approach this maybe using a little small table and apply a few points? Okay, so on the first one, please tell me first though, before I use a table. Can anyone describe what this would graph into? The one in black.
Parabola.
A parabola, and they're saying not all the parabola, just the part to the left of 0. So you would not necessarily have to plot points if you realize that, but plotting points would definitely help you to see. So to save me a little time, this is what I'd like to do here. See if you guys will agree with that first piece. It's looking like this. Guys, are you telling me maybe in the black here, this is going to be open and maybe something like that for the first piece? Without forming a table? Is that true? Okay. Now, next one, I guess I don't think you need a table for that, but you can do a table. It's in the blue there. It says 2 if you're caught between 0 and 2. You guys make sure I do this. Now, can someone describe for me what this might look like in blue?
Straight line.
Piece of a straight line, exactly, caught between 0 and 2, including 2.
Yeah.
Let's do this. Let's go up to 2 to get ready for it. And yes, if you guys agree, a piece of a horizontal line that might look like that. Would you guys agree?
Yes.
Yeah.
Okay, and no table needed. Now the next one, I guarantee you I've got students who can do it without the table. If you need a table, this one looks a little strange. The reason I brought it in, can anyone describe for me what the red would graph into? Describe for me. And maybe we would not have to use a table. Or graph into a parabola upside down?
Yes.
Yeah, reflected through the what, x-axis? And then horizontally shifted 2 to the right?
Yes.
And then what? Up 4. So if I keep that all in my mind without constructing a table, that would be beautiful. But if a table would help, go for it. And all this is supposed to be taking place here. X is greater than 2. Well, I'm out at 2 already. So guys, if I can attach to this a parabola, opening down, shifted 2 to the right, up 4, and let me go ahead and get that 4 ready here. Let's see if you guys will accept this. And by the way, I noticed at the very beginning, that's not, it says x is greater than 0, not to be included. Am I going to do this first? Is it out here, here,
Yes.
right? And then it's opening what, down?
Yes.
So if you say just, Professor, I can just do it right quickly. And I guess it goes through what, infinity?
Yep.
So would that be it done? Without constructing, we're using a table for each one. Now guys, definitely can plot points if you wish. And that's the graph of that piecewise function. Done. And it would pass the vertical line test. Now, can anyone look at this and tell me the complete domain? I mean, all the pieces put together. What would you accept as the x, the extent of the x's of the domain?
Negative infinity to 0, not including 0.
Okay, negative infinity up to 0, and you're saying do not include 0.
Then union
Union,
0, not including 0 to infinity.
0, not including 0
Yeah.
through infinity. Would you guys agree with that? And if you don't see it by looking at the graph, sometimes that graph has so much going on. You could do this. These are the domain items, the x. X is the domain. You could say, Professor, without looking at that graph, I might do a visual here. One part says x must be greater than 0, which is like this. One piece. The other piece there for the domain says you're caught between 0 and 2. So let's go out to 2. Let's see if this will make sense for us. That's to be included.
But wasn't the first one x less than 0?
Was it all of it? Yeah, geez. Hang on. It's the wrong piece. Okay, x is less than 0. That's my first piece, right? The blue one says now you're caught between what? 0 and 2, including the 2. So that would be, visually, is that? Here. And the red says now extend that out to the right of 2. And would that be, for the third piece, this? And guys, now if you look back, is that what we said would be the domain back here? So visually, it agrees. So could we do something like this? Definitely you could. Now those that you're with me. And I'm going to do one more piecewise function for a reason. Since the course is over, you may see something like this. Sketch, say f of x is equal to, and it looks like this one also has 3 pieces. This, if this, okay, blue for the second piece. Second piece looks like this. And the third piece looks like this. Let me step back and make sure I have everything copied down correctly here. Looks good. Now that would be a little bit more challenging. But the pieces could contain items like that. So guys, let's see what this might look like sketched with your help here. Now, if it requires a table for you guys, go for it. If you think you know what's going on here, we can just look at it and get the sketch done. Now, someone tell me, how would you approach sketching the first piece?
It's an exponential, right?
It's an exponential.
The paragraph?
Absolutely. So I know the parent graph, which is like e to the x.
Yeah.
I know what that graph looks like. They all sort of look like, see if I'm saying this correctly, they look something like this.
Yeah.
So that's a regular e to the x. All this is supposed to be taking place where x is less than -1. Now if I plug that endpoint in, -1, right here, that becomes what? -1 plus 1 gives me what? 0, e to the 0 gives me a 1. So it might say at -1, is that sort of the stopping place for that little piece, at -1? And we've already said if you replace x by -1 and do the math here, you end up with what, 1? So -1 up 1. Let's see if you guys will agree with this. It says here, am I supposed to, have it to stop there?
Yes.
Yes.
Is that true? Or you could plot points. Okay, we got that one done. Let's the blue one may not be too bad. It says negative x if you're caught between these two. So negative 1 will go out to 1 since we're using it. Guys, what you could do, if I take negative 1, plug it in here right quickly, I get what, positive 1? So negative 1 up 1 should be open. In fact, it was open from the previous piece, wasn't it?
Yep.
And if I go out to maybe a 0, 0 could be used here. 0 with 0, so I know that's right here. The endpoint 1, put a 1 in there, you get negative 1, so I'm down here at negative 1, and that looks like it's not supposed to be included. Are we looking at something like that? The true? I should have placed that in blue there since that's the blue one. Now, ln of x. And here's my restriction. You guys remind me what the ln of x, a log graph, looks like.
The inverse of an exponential.
Okay, the inverse of the what? The exponential? I got you. And the shape would be, this is the exponential here.
Yes.
So does the log do something like this?
Yes, it goes through like 1.
That's true, guys? That's the shape of the log. And it says I'm considering only which piece? Greater than or equal to 1. By the way, if I put a 1 in there, that's my endpoint. ln of 1 is 0. So that says, does it start right here? Yes or no? Okay, and then the piece itself, you guys, when it looks up like this, am I just looking at this piece? Is all that making sense, guys? Let's just take a look at the pieces there. Okay. Do we agree? Okay. Now, can someone tell me what the domain on this one, if you're asked about the domain? Now, you could look at this to find the domain.
Negative infinity to negative 1.
Okay, negative infinity up to a negative 1. Let's see. Hang on. Tell me more.
Union.
Is there a union with this?
Yeah.
Union like what?
Negative 1 to infinity.
Negative 1 through infinity is negative 1 open
Yeah.
Yes.
through infinity. Alex, you're saying that?
Yeah.
Okay. Would you guys agree?
Mm-hmm.
Okay. Woo! Let's see if I got anything else to say here. I guess that might be it. You guys agree with that domain? Okay. Mr. Parker, you agree with that domain? The domain on that graph? Okay. Okay, guys, so be ready for a piecewise function. That's the way more than likely your test will open up. It'll probably open up for the piecewise function. Could be one more like this. Could be one more like this. Yeah.
Is the range all real numbers?
Oh, beautiful. Let's get the range. Bella, thank you. The up and down.
Negative 1 to infinity.
Does it drop down to a negative 1 for the lowest?
Yeah.
Yeah.
This one does. And does not include. How high up does it go, guys?
Infinity.
Infinity. Right? I don't think we listed the range on this one, did we?
No.
Okay, here it goes. Up and down. Right, it's going to drop down forever. Now, how would you describe how high up is it going from there? Is it also, this picks up infinity? Would you guys agree?
Yes.
Woo! Okay. Let's see if there's anything we should be careful about. I think that might be it. Okay. Now, guys, I'm not going to have the time, but you're responsible for graphing up just a piecewise. I'd bring those in. Log graphs, we had a log graph here. Trig, you just had a test on that. Rational functions, that wasn't too far back. And the P of X where it touches, crosses, end behavior, and all that business. You have to be responsible also for that. So lots of sketches to be done on this final exam. Okay, I'm gonna erase part of this. Are we okay with this? Now let's follow this handout because I think it's a beautiful review here. Now I know you guys have been busy, you probably have had other exams, but I'm sure some of my students have had a chance to look at this. Part 2, Find the domain. I got a string of domain on the test. And the first one says, it looks like this. F of x is equal to ln 4 subtract x squared, no graphing required. I just want the domain. What should I do?
4 minus x squared greater than 0.
Thank you. For a log, by definition, this part, as Nasir said, must be that. Think it's that factors? I would not move that x squared over, I would go ahead and factor. And you got that. Now tell me, what do you think it's calling for me to finish up and find the domain?
Line analysis.
Sign analysis. And if I use sign analysis, I'll use it just beneath here. Guys, my critical numbers are 2 and -2. See if you guys agree. And it looks like they're open. It's good practice for sign analysis. Okay, to the left, since I have not seen sign analysis for a while, let's go through this. In between, out here, out to the left, a test number, that definitely is up to you, and we'll try -4. In between, we'll try 0. Out here, we'll try maybe a 5. Now, if I replace x by -4 here, testing, 2 subtract a -4 becomes 2 plus 4, so that's going to be a positive. And replacing x by a -4 here gives me a -2, a negative. And it looks like I'm looking for something for a result to be positive, so that's out, will not work. Let's try 0. 2 subtract 0, of course, is 2, positive. 2 plus 0, positive. And definitely that will give me what I'm looking for to satisfy the inequality. 5, I doubt it works, but here goes. 2 subtract 5, of course, is -3. 2 plus 5 is a +7, and will not work. Domain, after all that work, is -2 up to +2. True? Okay. And I think on this handout, one more of these domain types, g of x is equal to square root x subtract 3 over x squared subtract 5x plus 4. Now, how should I start in this one?
You
Find the domain.
you factor the bottom.
Factor the denominator first. I think this will factor x minus 4 and what? X minus 1?
Yeah.
Okay, what else should I consider?
Can you do x minus 3 is greater than or equal to 0?
Thank you. Since that's a square root, for that square root to be defined, this must be greater than or equal to 0. Which implies that x must be greater than or equal to 3. So guys, with all this going on in the red, the blue, domain, I've got everything greater than or equal to 3, but I cannot use 4,
Or 1.
and I cannot use 1. Well, we lucked out here visually. Now, this is not sign analysis. Visually, what's going on here is, yes, greater than or equal to 3 looks like this. That's what that looks like. And I cannot use a 4, which is out here, open, and also I cannot use a 1, which is back here. It's just the way it looks, visually. So my domain would be, what?
3, 4.
Bracket, 3 up to 4, union what?
4 to
4 through infinity. There's my domain. Need not worry about this 1 to the left. Look pretty good? Okay. Make sure you understand how to find the domain of any function. Next it says find the complex zeros. Now we have not done one of these in a while. Part 3. I gave you p of x is equal to this. plus 23x. Oh, minus 5x squared. Plus 23x plus 10. You guys make sure I have all that copied down correctly. Okay, it says find the complex zeros and write the function in complete factored form. Does anyone recall what would you do first
Synthetic division.
to begin?
Synthetic division.
I'm going to do synthetic, substitution or division. And by the way, how many zeros am I expecting?
4.
4. So I gotta get 4. And among those 4 might be some I's involved. So guys, did you want to use Descartes' rule of signs to see the positives and the negatives?
Yeah.
Some students will do that. The number of sign changes, I see one sign change immediately, and I see another sign change here. I think I see 2 sign changes. So it says the number of positive real zeros will be 2 or what? None. Now to find the number of negative real zeros, the process says, by Descartes' rule, p of a negative x. So guys, if I go back and replace all those x's by a negative x and I cleaned up correctly and not make a mistake, I think it's going to look like this. And let's see if you guys will agree. Is that the way it looks? If you go back and replace x by a negative x, and you cleaned up? Yes? No? And then count the number of sign changes there. The first sign change I see is here. Oh, and there's another one here. So for the number of negative real zeros, again, what? 2 or none. Okay. Now, how am I going to find them? P over Q, the rational zero is 0. So guys, P over Q, where the P should be a factor of what? My constant term? And I got down the end there, it looks like maybe a 10. So let's write the factors as plus minus 1, plus minus 10, plus minus 2, plus minus 5. The Q factors of my leading coefficient understood to be a 1, so it's plus minus 1. Now, this is where it gets a little tricky. Does anyone have a favorite coming out of those possibilities that maybe by synthetic we can test? And maybe it will work when I set it up.
Let's try 2.
Okay, let's try 2. So let's see, 1, negative 5. Another negative 5, 23, and a 10. And I heard what, try 2?
Mm-hmm.
Okay, let's try 2. 0, 1, 2, negative 3, negative 6, and negative 11 is it? Negative 22, whoa, 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 whoa. Did I make a mistake?
Negative 2
No,
words.
it's negative 12.
Oh, you want negative 2,
Negative 2.
not 2. 2's not gonna work. Erase real quickly here. You guys want negative 2 test. Okay, you go 0, that'd be what? Negative 2, negative 7, what's that, 14? Help me out. 9, and negative 18, what's that, 5? And looks like it might work. True?
Yep.
Now, if you should stop at this point, you know it may help and it may not. The remaining numbers at this point tells me I had an x to the 4th, so this is like an x cubed at this point. Subtract 7x squared plus 9x plus 5 is equal to 0. I just thought I would mention that. But guys, I don't think that in the red will factor for you. I was hoping it would. Okay? But I'm sure there's ways to deal with it, but it's not going to factor nicely for me. So I'm going to just continue with the synthetic. And does anyone have a possibility for another?
5.
I heard 5? Let's try 5. 0, 1, 5, -2, -10, -1, -5. Looks like it works. Now, we got 1 negative, 1 positive. Descartes telling us we should have what? 2, I guess? Or, well, we should have 2, shouldn't we? It says 2 or none, but it looks like at this point, maybe I should have another negative and another positive. Let's see what happens. How am I gonna find what's remaining? Well, we'll find out. Finally, these remaining numbers names forming what?
X minus 2x squared.
There you go.
X squared minus 2x.
Looks like that? True? Now, will that factor? No. So if I use what here? Quadratic formula? If I use quadratic formula and I'm careful, it's gonna be what? 2 plus minus square root, help me out guys, 4. Subtract 4 times 1 times a -1 if I'm careful, all over 2. So this is 2 plus minus square root, I think that's an 8. I think, underneath there. And this is 2 plus minus radical 8 simplified, is that? Reduce this down, please tell me, am I concluding with that? Is it true? So it looks like at this point, there's no mistake, I do have 4 zeros, and they are, and I'll list them here. By the synthetic, we got -2, 5. If I separate these, I got 1 plus radical 2, and 1 minus radical 2. And those are my 4 zeros. By the way, Descartes says I should end up with what? 2 positive, 2 negatives. Do I actually have 2 positives and 2 negatives here? Yes. Now I also ask you now to take those zeros and place them or rewrite the function in factored form. So guys, let me go back over to my function right here. I want this factored based on what the zeros were. Can someone give me a start?
X plus 2.
Definitely x plus 2.
X minus 5.
Man, you guys are ready for this already. X minus 5. Now be careful, tell me the best you can to get this.
X minus 1 minus root 2.
I love it. X minus 1 minus radical 2. And the last one to get,
Minus 1 plus root 2.
okay, x minus 1 again, but what? Plus
Yeah.
radical 2, and there you go. That is in complete factored form. Whew.
Would you make us simplify x minus 1 minus root 2, x minus 1?
Alex, I was hoping someone would ask that. Guys, if I should, you've seen me do it in class, especially if we have an I there, remember? I asked you to consider this right here. Oh, I'm glad you asked. This right here, I think I grouped this for you guys into like an A minus B. And if I group this one, what, A plus B? That's true? So this came out to be A squared minus B squared, Alex. I'm so glad. That's what, X squared?
Yeah.
And B was a radical 2, so that's what, radical 2 squared? Oh, that's what, X minus 1. But you gotta cover something up there. That's true, guys? Is that my A squared minus B squared?
Yeah.
A is X, like X minus 1, this is the X minus 1 here, and there's the radical 2. So it's going to give me an X squared, subtract 2X plus 1, if I expand it, minus what, 2? Or altogether X squared minus 2X, these two put together will be what, minus 1? So that'll take me right back to where, somewhere in here, all this work.
At the end of synthetic.
Somewhere back here, I think it was, right here?
Yeah.
Just takes me right back. Okay. Woo. Would you guys like to start the first part of the test now? And get at least the first part done? So you page 1 of the test? Wouldn't that be nice if we pass out page 1 of the test and we can get that done tonight? Okay. Okay, guys, any questions there on this? Now, next it says solve. Oh my goodness, solving equations, all types of equations here. And the first one looks like solve this. This is part 4, guys. E to the x, subtract 12, e to the negative x, subtract 1 is equal to 0. Okay, so we'll give you an idea how to get started.
Would you like let U be something?
And absolutely, if you want to jump into that right now, let U be something, it's possible, now be careful what you let U be. But here goes. Like what?
Could you first multiply everything by E something? I don't know.
What's that something? You're on the right track.
E to the X.
E to the x?
I think. I don't know.
He said, Professor, you could multiply all the terms by e to the x. If I do, and Alex, if I try that, here we go, which is valid, it'll work. And be careful here. E to the x times e to the x is not e to the x squared.
2x.
It's e to the 2x. You add the exponents from middle school. Here's nice, because it comes what, e to the 0? We add them up, which is 1. And of course, you end up with minus 12 then altogether. Down here, the 1 times e to the x gives me minus e to the x. Of course, the other side is 0. Which helped. If I place this in order, it's out of order. E raised to the 2x, subtract e to the x, subtract 12 is equal to 0. Guys, I just rearranged it. Now, Alex, what do you think I should let u be now?
E to the X.
E to the x. Absolutely. Because this that he has come up with is e to the x squared, another way to represent it, and therefore he's going to write this as u squared. Of course, in the middle there, u, subtract 12. It's amazing how math works. This mess is this. And we can deal with this down here. This easily factors into u subtract 4, I think, u plus 3. That's going to give me a 4 to work with. Also, it's going to give me a negative 3 to work with. And guys, I got e to the x equals 4. E to the x equals negative 3. Now, how about x itself? What would you do now to find x?
X equals ln 4.
And that's it. Just read this as it should be read. That's ln of 4. If I try it on this one, what may happen? I might end up with ln of a negative 3, which is outside, wrong. So we have to disregard this one. Mark it out, guys. So after all that work, with his help, we have ln 4. I would give you full credit for that. Some students may get clever and say, Professor, could I rewrite like this? ln of 2 squared.
Yeah, 2 and 2.
Exactly, bring that 2 out front with the property of logs. Could be expressed like that. Guys, anyone with me? Nelson, you got your paper there with you?
Yeah.
What's the second equation?
Log base 2
Hang on now. Log base 2.
of x plus 2
Okay.
plus log base 2, 2x minus 3
2x minus 3
equals
equals 2?
2. Mm-hmm.
Okay. Now we're back into logs. How are you going to approach this?
We're gonna multiply.
Is that product?
Mhm.
Product property? So rewrite those logs as a single log, base 2, and the product, with the help of the product property, x plus 2 times 2x subtract 3 is equal to 2. Now what?
2 to the power of 2 equals that.
I love that. You know what this means? It means at this point, base 2 raised to the second is equal to this expansion. Let me go ahead and expand that out. What is that? 2x squared, I think it's plus x. Subtract 6, if you guys agree.
Yeah.
And again, look at math. It took this and goes down to this. Guys, this is 4, of course, is equal to what? 2x squared plus x, subtract 6. Do not let me mess up here. Move that 4 over, subtract it, and you end up with subtract 10.
I'm not done, I was just wondering if I could use the restroom.
Yeah. Is that true?
Mhm.
I'm hoping that that will factor. We'll see if it does. And make sure you see all this on the board, guys. 2x, x. Oh my goodness, maybe what with what? 5 here? And a minus 2 here? It wouldn't factor? And if I split these up quickly, I see x is equal to what? Negative 5 halves, and x is equal to 2. Now, we think at this point, we guys will do it like this, but we think at this point, we have this. Now you're going to turn your paper in with that? No, because I think one of those has to be rejected. Which one?
Negative
Negative
1.
one.
This right here. Why?
If you plug it in, it becomes a negative log.
Yeah, if I replace, for example, exactly, if I replace negative 5 halves and negative 2 1/2. Negative 2 1/2 plus 2 gives me what? Negative 1/2?
Yeah.
You cannot take the log of a negative number ever. So that's out. You can also have checked it by looking at the domains of these two. I think I showed you that in class also. Okay, guys, answers 2 then. After all that work. Now, see, was there another one there?
Yes.
Okay, now guys, if I go over this side, can you guys see? Mr. Parker, if I go over here, can you record okay?
Yes.
Is that looking pretty good?
Mm-hmm.
Okay. Nothing.
This will be cosine 2 theta
Oh,
minus cosine theta equals 0.
now we're getting into some of the most recent. Well, you gotta be careful. You have to be careful. Take a look at it. Someone give me a suggestion. And then, oh, by the way, nothing was from 0 out to 2 pi.
Yeah.
Would you make
Yes, it's pretty good. Okay.
would you make cosine 2 theta into 2 cosine theta squared minus 1?
This is a double angle. You gotta use a double angle formula. In fact, I think it's one that has 3 versions. Alex says the best, I think, for this particular equation would be,
I forgot it.
The one with cosine.
The cosine.
the one with
squared
cosine in it. Which one is that?
2 cosine theta squared minus 1.
2 cosine squared theta minus 1 is a formula for cosine double theta. I think the others were cosine squared minus sine squared. And it seems like there's 1 minus 2 sine squared maybe. Yeah, check there. Then we still have this. Now this is looking better now. Rewritten in the order, should be written 2 cosine squared minus cosine, just rearranging, minus 1 is equal to 0. Now what?
That u equals
Oh man, great. Let u be in this case cosine theta, and here we go at the math again. You're going to end up with 2u squared, subtract u, subtract 1 is equal to 0. It's amazing how math works. All right, let's start with this. This will factor. u. Now guys, I think it's a plus 1 and a minus 1. Check my factoring out. Is it? So you end up with u is equal to what, -1 maybe? -1/2. And down here, a +1. Therefore, now I'm looking at, for u was cosine, so this says cosine theta is equal to a -1/2. And this says cosine theta is equal to 1. Now, you gotta know the unit circle. Where on the unit circle have you seen the x-coordinate, which is cosine, equal to a -1/2? I'll start placing solutions.
Quadrant 2 and 3.
Tell me again.
Quadrant 2 and 3.
Quadrant 2 and quadrant 3 is where it's located. Now, what's the size of the angle in quadrant 2?
120, I believe.
Beautiful. 120, or in radians?
2 pi over.
Beautiful. Now, see, you said the other one, because cosine's negative also in quadrant 3.
Yeah.
What's the size of the angle in quadrant 3?
Probably 4 pi over 3.
4 pi
Over 3.
over 3? I know this, guys. That would take care of that. That's done. Now, where do you know cosine is equal to 1, the x-coordinate?
0.
0. The very beginning.
If you put 2 pi instead of 0, would it still be correct?
No, you know why? Because your textbook says do not include 2 pi.
Oh, okay.
So more than likely, now, Alex, if I did this,
Yeah.
then you could go ahead and also say 2 pi.
Yeah.
0, 2 pi, both of them would work. Okay. Ignacio, is that the last one on the equations?
No, we have one more.
Okay, what's that?
2 sine of 3 theta
Uh-oh. Okay.
minus 1 equals 0. So
Okay.
that is
Guys, is there a formula from class for sine triple theta?
No.
No. You could do one, maybe that would be a nice little extra credit. You could actually derive a formula on your own for sine 3 theta. In fact, I think I mentioned that in class. But I don't think I need it here. Can I just merely move the 1 over and have that divide by 2 and have this to consider? Yes or no? Now, be careful on this last equation. I know and you know you're going to be searching for when that happens first. Where have you seen the y sine equal to a 1/2? And since that's a positive 1/2, it's either what? Quadrant 1 or quadrant 2 for sine. So in quadrant 1, can anyone recognize from the unit circle where was sine 1/2 to begin with? 5 over 6. So that says this is representing pi over 6, and could be more revolutions. I'll write this as 2 pi, the period number. Did we use a k or an n?
I think it's N.
N? Okay. Where n is an element of the integers. And I'll come back to that. I'll put the word or here. And where else have you seen besides pi over 6 sine equal to 1/2 over in quadrant 2?
5 pi over 6.
5 over 6, so that means that 3 theta, wow, nice. Could be representing 5 pi over 6 plus, I'll pick up all of them, 2 pi n, where n is an element of the integers. Guys, now I gotta go back and solve for theta, and I'll be careful here, be very careful. Divide by 3, all this is being divided by 3. Cancel, so you got theta. Theta is equal to,
pi over 18.
it is pi over 18, strange. And it's even stranger,
So it's 2 pi.
now you got it, when you do it on this term. What's that, 2 pi over 3? N, the over n is an element of the integers. And guys, there's my first so-called general solution on that. Gotta do the same thing down here, divide by 3, solve for theta. And we'll end up with theta is equal to, guys, I think this is 5 pi over 18, is it?
Yeah.
What a problem. 18, of course, 2 pi over 3 for the second term. N, where n is an element of the integers. There's my second general solution. Okay. Tori, can you see all this? I'm way over here. Tori, you okay? Okay. Whew, I'm gonna list the answers up there. Guys, remind me, how did we do this in class? How did we list the answers on one like this? Yeah, I started with like NB1 or NB2, NB3. Could try that NB0 and find all we need. Now, Ignacio, was the restriction still find them caught between these?
Yes, there is.
Okay, and to help myself out, I see some strange numbers coming out like pi over 18. Oh, and they get even stranger. Let's write some of them out and we'll see. Let's go to the first one, guys. I'm going to here so you can see. Let's let n be, now if I let n be 0, that means this term would drop out and leave me pi over 18 as a solution. If I let n be 1, back here again, this becomes 2 pi over 3. Combine these two with a common denominator of 18, guys, help me out. Does anyone see what it is?
So it's 13 pi?
It's 13 pi over 18. Now see, an 18 coming out quite much, so I'm going to do this. The restriction was, let's change this to 0 out to, I'm seeing an 18, what's that, 36?
Yeah.
Pi over 18 is better. And right now, these are caught between those two. I might find another one, we'll try it. N is equal to 2. In this case, if I replace n by 2, guys, this becomes 4 pi over 3. Combined with a common denominator of 18.
25 pi.
It is 25 pi over 18. Are we still okay here? Wow, maybe I can find another one. Let n be 3. You keep going until you go outside that restricted interval. If I put a 3 in there, guys, this becomes what 3's cancel. Because they give me a 2 pi, see right now it's going to go beyond 2 pi. I got to stop. So right now at this point, guys, I have 1, 2, 3, 3 particular solutions, and they are these at this point. Now, to save me a little time, what must you do in addition to that? Same thing down here on this one. I think you'll get 3 more. I'm not going to do that one down there for you, but you should also include this one. I think you're going to end up with what, 6 zeros altogether. Okay, take a close look at it. Ignacio, is that the last one on the solving equations?
Yeah.
Okay. Guys, any questions on solving equations? I think this is going to benefit you in preparation for the test. Okay. Ignacio, let me move here to this board. Over here on the side. What is the next part?
Find the difference quotient.
Oh my goodness, we have not seen a difference quotient and I don't know when. Does it have anything about average rate of change?
It doesn't mention anything.
It doesn't mention anything about average rate of change. Did we discuss average rate of change in class? Yeah, in fact, I think so on one of your tests, so you could be also responsible for average rate of change. Did it mention anything about an equation of a secant line?
Not in here.
Or was that on one of the tests also? You remember the equation of a secant line? You don't know it all. But at least let's get this difference quotient. What was the function?
For f of x equals x squared minus x.
Oh, that was too easy. X squared minus x?
Yep.
And he said, Professor, the asked us to find this, called the difference quotient. Gotta be careful though. Guys, I'm gonna do this part first. In that definition, it says go back to the function he gave me in the blue there, replace those x's with x plus h. And And I'm looking at, if I'm careful, that. And I'll mark that out to show that's done. Don't stop there, now it says subtract on the end this, which is merely my original function. And don't stop there, divide all this by h. Is that the way the difference quotient works, looks? Now, when I clean this up, what's supposed to happen if I do it correctly to this?
It drops out.
It cancels. So let's see what happens, guys. To clean this up, I'm gonna expand first. X plus h times x plus h. X squared plus 2xh plus h squared, done. Here, a negative x minus h, I got a distributive property. Here, another distributive property, distribute the negative, negative x squared plus x all over h. Some of these terms will cancel. X squareds are gone, x's are gone. That leaves me 2xh plus h squared. And it looks like what? Subtract h all over h. Now, what would you do?
You will factor out the
You
h.
gotta factor the h out. There's a common factor of h in that numerator. If I take the h out, that's a common factor, 2x plus h minus 1 all over h. And yes, finally, this happens. And 2x plus h minus 1 is your final answer. Bring back some fond memories? Well, of course it is. Now, I don't know, I think I mentioned this to a couple of students earlier. If, and it could happen since your course is over, the function could look like this. I don't know how crazy I'm gonna get. Could be sine x. And they want you to write the difference quotient for it. Okay, you want to tell me what that difference quotient for sine x would at least look like?
Sine of x plus h
Sine of x plus h.
minus sine of x.
Nice. Subtract sine of x. All over h. At least I know what it looks like. Now, I don't doubt if I would do this, but who knows? Can anyone tell me what you would have to do further if you should see something like this? What else could you do at this point? Because this has got to go eventually. I wish it would go now, but will not.
Would you do sine x sine times x and sine times h?
Oh, you're talking about this. This takes the form of sine a plus b. He wants you to use the sine a plus b formula. You could. You could use the sine a plus b formula and express sine of x plus h, and then try it from there. Guys, I know this one from calculus. Even after that, it's going to be a little bit more work done to it. But at least you could express the help of the formula. Okay? I would throw that out. Could be a log. I asked you to find the difference quotient on. Could be a log function. You're hoping it's one of these.
Yeah.
Right? You're hoping. Okay. Ignacio, what was next?
It says applications.
Oh. Did you say applications? Did I have samples there or not?
It just says area, projectile, half-life, max, min, using x equals negative b over 2.
So the big thing comes down to, we had some word problems on some exams. It comes down to this. When was I using negative b over 2a? Negative b over 2a. What type of situation would I be in to consider negative b over 2a?
Complete the square.
I could complete the square. Something else. When did that come up so often? negative b over 2a. Thank you, replace the part of the vertex, forever. Now besides the vertex, what else? Now wait, Hannah, nice. She says, Professor, I remember now either that's happening or this is happening. And this right here is called the vertex. And I can use negative b over 2a in my attempt to find the location of the vertex. Besides being the vertex, in this case it would be a maximum. In this case it would be a minimum. So I would use negative b over 2a in a situation like that where they may ask me to find the maximum area. So if they ask me to find the maximum area, I gotta turn to this. Right? Did we do some maximum areas in class? Right, on one of the exams too, right? But you're telling me I have no examples there.
Yeah, there's no.
I just mentioned that.
Mhm.
Okay? Does anyone, guys, before I leave it, does anyone have one there handy? Where they ask you to find the maximum something, maximum velocity, no, what was it, maximum height? What's the maximum height an object goes up to? You remember those problems? We had to use negative b over 2a, it's like Hannah said. That's where that would be used. So look back at your old exams, if you find it before we leave, I'll work out one. Now see what's next.
Then it says exam 5 topics.
Oh my goodness, we're doing exam 5, you guys just had exam 5. Already?
Yeah.
Wow. Okay, any particular examples there, or just, no, huh? Okay, now what's next?
Then it says sequences, series, and summation.
There you go, the new stuff. Real new stuff. Now, did I have some examples there?
It just says binomial theorem,
Okay.
and then given a1 equals 3,
Oh, hang on. So given a1 is 3,
a7 equals 2a7 minus 1
okay,
plus 1.
plus 1. And what did I ask for this? It's called a recursive sequence.
Yeah.
What did I ask you to do?
It says recursive formula, write the first 5 terms of the sequence.
Here we go, hang on. Find the first 5 terms that this describes. Okay, guys, does anyone recall how to do this when you see one of these? Because you will see one of these.
You plug it in,
Yeah, but when you say plug in, where? What?
so you plug in 2.
Okay, did they give you the first term?
Yeah.
Thank goodness I put 3 on the first term. That's the first one. Now to find the second one, a subscript 2, let n be 2, I must do this. 2 times a subscript 2 minus 1 plus 1. Try to find the second one. And he gave me the formula there. So a subscript 2 would be equivalent to 2, a subscript what? 1?
Yeah.
Plus 1. And they gave me a subscript 1, the first term was merely, what, 3?
Yeah.
Do that math, please do not let me mess up. Is it 7?
Mhm.
So that's my second term. Third term. A little tedious, but works. Third term, a subscript 3 is equal to, with what he gave me, 2. A subscript 3 subtract 1 plus 1. So this a subscript 3 is equal to 2, a subscript 2 plus 1. Third term would be 2 times a subscript 2. Guys, we found a subscript 2 to be what? The second term, 7? Do the math there, I think it's 15. And you guys can finish it up. You see the routine here?
Mhm.
Now, the only trouble here is, how could I lose points, Professor? Looks pretty easy. It is easy. If you make a mistake, and we all make mistakes, and for example down here, you did not get 7, you got 8, for some reason. But here, then you're gonna miss the next one. And if you miss that one, you're gonna miss the next one. So that's the only catch on this. Okay, guys, so you can finish that up and find the other terms. Nacio, what else do we have there?
We have a summation.
Hang on. We had, what was it?
Summation from k equals 1 to 52.
Oh, summation. Okay, here goes. Now start with 1,
Yeah, all the way to 52.
52.
Yeah. Of 3k minus 5.
Oh, nice. And I may ask you to write out and express to me what you think that means first. Then we'll try to find the answer. Guys, if I start out with k is equal to 1 and put a 1 in there into the expression he gave me, I'll end up with -2. If I put a 2 in there, I end up with 1. Let's try one more. If I put 1, 2, put a 3 in there, do I end up with a 4?
Yeah.
Yeah. And he's telling me, Professor, keep going until you replace k by 52. So I replace k by 52, that's 156, subtract 5. Help me out, guys. 151? I did that quickly. Is it 156, subtract 5 or not? 156, is it 156?
Yeah, it is.
Subtract 5? Is it 151? You guys agree? Is it 151? Now, Billy, you're going to say, okay, I'm going to get a good score on this test, Professor. You know you're never going to have time to add these up. I'll have some students add them all up. You never have time to do that. So how would I find that grand sum without adding directly, which would be so time consuming? Who recalls?
Split the summation.
Okay, first split it up. So the summation can be by properties, be split up like this. One through 5. Where was it here? 5. Now 52. 5. Let me step back and look at it. This one, guys, split up now. And now what? Formulas would help me. And you gotta know your summation formulas. I could pull the 3 out front. We've seen that before. That would help. And that would leave the summation in good form here of merely k. This one, guys, I think is probably the easiest one. I can go ahead and calculate it right now. What should I do there for that constant 52 being, the 5? 5 being added 52 times. Let's multiply these two together. And 5 times 52, help me out, 260?
Yeah.
Yeah.
Okay, so I'll get that one out already, out of the way, that's down here. Now, how are you gonna deal with the first one?
Add k times k plus 1 over 2.
Beautiful. Gotta know your formulas. This is like Mr. Gauss's formula. N times n plus 1 over 2, so in this case 52 times 53, all over what, 2? I still got this down on the end. You guys agree?
Yep.
And then, of course, you would have to crunch that out if that should happen. Not that I'm gonna crunch it out for you, but that you'd have to crunch it out and get an answer. Okay, that would be a summation. Right? Okay. Suppose it didn't happen here, but suppose this had been this. K squared. Was there a formula also for summation for k squared? You gotta know that formula. If there's a k squared, and there's another formula to be used, not Mr. Gauss's formula. Ignacio, we're going through this fairly fast. What time did I say we're going to stop? 6?
Yeah.
Oh man, we're doing great. What's next?
It says conic.
Oh, whoa, really? That's the end of the page?
Yeah.
Okay, the conics. And I think Monday, I mentioned what they want is parabola, ellipse, hyperbola. Did I mention some of those words?
Yeah.
On Monday? So if anything at all on the test, I may ask you to sketch. Maybe something like this. Give me a quick sketch of that. Now, does anyone think from Monday, this is the first time you saw it with me, do you think you recognize what the shape might be when I finish up?
Hyperbola.
It's called a hyperbola. One that has 2 branches. To graph it, easily done, but first we recognize, guys, this is 5 squared, which would help. And this is what, 2 squared? And if I go to the grid, and quickly get a shape. What you see here, that would tell me the x-intercepts are located where? Plus or minus 5. The true, the x-intercepts. Okay, so out 5, -5. I know for sure those are my x-intercepts. Y-intercepts?
None.
None.
Okay.
We talked about that Monday. But if I should use the numbers coming out, the numbers coming out though would be what? 2 and -2. Not as y-intercepts, but for another reason. Guys, let's do that. And this is so easily done now, just sketch or construct a rectangle going through those. Now, who recalls what was done next?
You do
Yeah.
the
Diagonals? Draw the diagonals in, extend them outside through the center. And this one, same thing. And now where is my graph?
To the right.
Yeah, I gotta pick up this x-intercept of 5, and therefore, and follow the asymptotes. One branch looks like that. Over here, pick up -5. Do we agree? So that's a hyperbola. You could also do an ellipse, easily done. Please do, that's it? Alex?
I found the maximum height problem.
Oh, we need one, hang on. Yeah, erase this. By the way, guys, at this point, has this helped?
Yep.
Okay, that's what I want, that should help some here.
Well, we're just pointing, we don't put the arrows to show that it's continuous.
What are you talking about? Oh, my mathematician in here? Jeez.
I'm just trying to not.
No, I know I got you. Professor, place arrows on those. They usually don't, but we will. They do go forever. Okay, Alex, what was that, maximum height type problem?
A stone is thrown upward from the top of a building. Its height in feet above the ground after t seconds is given by h of t equals -16 t squared plus 48t plus 32.
Hang on now. Okay, now hang on, you said we're on top of a building, I think, right?
Yeah.
Top of a building, and something being projected. Like that, and they're asking for the maximum height.
They also ask the time to reach maximum height and then time to hit the ground.
Okay, the time after you release it from the top of the building, does it take to reach its maximum height? And at what time will it finally hit the ground? Guys, these are probably the easiest of the negative b over 2a types. He's given the formula. Does anyone recall how does one start?
We should divide everything by -16.
No, you could, and then you complete the square and all that business, but something faster. Yes, come again. The vertex. And to find the vertex, I think Hannah told me earlier, is that still, in this case not x, it's a t, can I still use this formula?
Yeah.
Absolutely. So if I use it, in this case, that will be equal to negative what, 48? Over twice and -16. Guys, looks like it's gonna be a positive answer, 48 over 32, reduced down by 16 into what, 3/2? Now I think this is seconds. That's the time, t for time. So it's gonna take 1 1/2 seconds for it to reach its maximum height. Now what is that maximum height? What should I do? Yeah, go back and find h at 3/2. And he gave the height formula to me. Yeah, this is a good one to look at. guys clean this up. By the way, this term, remember, we canceled 2 into 48, to fairly quick, 24, what is that, 72? I'm just doing math, 32. Well, canceling here, -4, what's it, -36? Plus 72, plus 32. It says 68. I did it quickly. I will put feet here. I think I heard Alex mention feet. Is it 68, guys? Okay, so the maximum height is 68 feet. And it's going to take 1.5 seconds for it to reach that maximum height. Alex, I think you had something else to be asked. What was the other part?
Maybe just how long it takes to reach the ground.
Yeah, now how much time will it take for it to hit the ground? Guys, when it hits the ground, something happens.
X is 0.
The height is 0. It makes sense then, if I answer that question, go back, this side is 0 now. And you are now considering this. Divide everything by -16 to reduce this down. Division by -16 will give me, let's see if it's going to work. Next one will give me that. Darn it, that will not factor. Guys, did I do that correctly? Are the signs correct?
Yeah.
I was hoping it would factor. It's not going to factor, so let's use quadratic formula. There goes. T is equal to 3 plus minus square root 9, subtract 4 times 1 times -2 all over 2, and see if you guys will agree with that. Let's make sure I put all that correctly into the quadratic formula. Yeah, looks good. So we're going to end up with T is equal to 3 plus minus square root of, what is that, 17?
Yeah.
17 all over 2. Now, the guys were talking about time. So if I separate those, which one should I accept?
Positive.
Yeah, 3 plus radical 17. 3 minus radical 17 is going to give me altogether what, a negative response? So the time would be equal to, for it to hit the ground, 3 plus square root 17 all over what? 2, and I think it's 2 seconds. Nice. I think we're ready for the test. Now, since I finished up all the items I brought in, let's see if I brought some more. Hold on. Oh, no. Oh, yeah. How about you guys try something for me? I brought one in. Myself here. I want you to do this for me. I'm going to give you a sum that looks like this. I want you to write that using sigma notation. Try it, then we'll work it out together. Rewrite that sum using sigma notation. And then find the sum. After writing sigma notation, go ahead and finish it up and find what is that sum equal to.
Is it 2 times k plus 7?
It is. Now go ahead and find the sum itself.
Should I come back right away or
Huh?
stay there for like 30 minutes? What do you want me to do?
Oh, you could just sit, you don't have to sit in the room with them.
Oh, okay, just
You sit on the outside, we won't turn in the math lab.
okay,
I'm gonna check and see how much time, come back and tell me how much more time you might need,
okay,
then go back.
okay.
Yeah, I know. Did you do? Definitely want to go 100%. I feel like we need 100% on this test. Bella SC is waiting for you. How much time?
He said like 30 or less.
Okay. Oh, you got a grand total? No. Okay, guys, let's do it. Now this index number, they call it an index number. The index number at the bottom there, we've been starting out with what, a 1? You can start with a 2, a 3, or 4, whatever you come up with, it'll work. Usually we start with 1. Now, did anyone come up with a formula to get those terms? I think Alex had one over there.
2k plus 7.
2k plus 7, look at this. Now let's check and see if that formula is appropriate. If I start out with 1, replace k by 1 in this formula, I'll get 9. Put a 2 in there, 4 plus 7, 11. Put a 3 in there, 6 plus 7, 13, it's working. Now I want to stop at 25, so what would I have to place here to get a 25?
9.
9. 2 times 9 is 18, 18 plus 7 is 25. Is that true, guys? So that's what I want there. Now, what is that grand sum? If you should add all those up, I would now use my formulas. We're going to move that 2 out front, which is allowed. And you're going from 1 through 9 of k. And of course, on the end, we're going from 1 through 9 of merely 7. Alex, you're making a mistake on this. So this is 2 times, here goes the formula, guys. It's going to be 9 times 10, n times n plus 1, all over 2. The last one's very easy, just multiply these two together, 63. 2's will cancel, we lucked out. So guys, it's what, 9e plus 63, is it?
Yeah.
Which I guess is what, 153?
Yeah.
That's the sum. Okay? Now, looks like we'll be closing out earlier than what I thought we would. Guys, I'm gonna do one more item with you, but I'm gonna take questions too. Are we okay with this? For the summation. Now, with that binomial theorem, which looks so strange. Guys, if you take a plus b, some binomial, 2 terms, and raise it to, I'm gonna call it n, that can be expressed as something called binomial theorem. That's strange. I'll give it to you on Monday. It's a summation. Does anyone recall what we started out with at the base for the binomial theorem? I think I used a j. Did I use a j last time? And then once we start out with always 0. Through n, I guess. Now, does anyone recall what the inside part looked like, which looked crazy?
N to J.
Beautiful. N choose J. A back here, A raised to the
N minus J.
N minus J. Oh, he's ready for the test.
Plus B over J.
B raised to the what?
J.
J. That's the way it would look with the binomial theorem. Now we'll try one with you, then we'll close down. Guys, if I ask you for an example, let's take, here goes, 2x plus 4 raised to the 5th. A binomial being raised to the 5th. First, show you what it looks like in the binomial theorem, the summation. Of course, we're going to start with 0 for sure, for the J, and 5. Inside there, guys, N choose J. I know what the N is. N is 5. So is it 5 choose J? Is that true? And then got A raised to the N minus J. A, in my case, be careful, is 2x. Raised to the 5 subtract J. That's N subtract J. The B on the end, B raised to the J, my B is a 4. So it's 4 raised to the J. Is that the way it looks?
Yes.
With the help of the binomial theorem. Now, I may, more than likely, I'll probably ask you to write out the first 2 terms, maybe. Altogether, there should be, how many terms, guys? 6? If we actually expand this thing out, it should be 6 terms. So I may say, take this that you have written right now and show me the first 2. So let's write out the first 2 terms. The first term would be, here we go, 5 choose 0, replacing J by 0. 2x raised to the what? 5 minus 0. 4 raised to the 0. Is that the way the first term would look? Then let's replace J by 1. If I replace J by 1, it's 5 choose 1. 2x raised to the 5 subtract 1. What was it? 4 raised to the 1. Is that true?
Yeah.
Okay, and I can write more, but if I just want the first 2 terms, and then I'll probably ask you on this to actually find what these are. I'm not going to ask you to expand the whole thing out, that would be too lengthy. I'll ask you to write a few of the terms out. So guys, I've just written the first 2 terms, and I'd like to know what they look like. Now that means you've got to know how to find 5 choose 0. Was there a formula for Monday?
Yeah.
It was like what?
5
N factorial? Help me out. Was it? What was that? 5 choose 0. Was there N choose J? Was there a formula?
N factorial over
N factorial over
J factorial
J factorial.
times N minus J factorial.
Oh, wow. Remember that formula, guys? I need to apply that formula. Alex, you are ready for this test now. Alex, you want to take it tonight?
Sure.
No. No. Okay, 5 choose 0. Let's do it. Guys, 5 choose 0. If I use this formula, let me use it right here on the side. That would be 5 factorial over 0 factorial, 5 minus 0 factorial. I don't think it's going to be very exciting, but let's see what happens here. Actually, I end up with 5 factorial. Just by curiosity, you know what means this. 0 factorial,
is 1.
always 1. Strange, but it's understood, except as 1. And of course, 5 factorial again. If you want to expand it, you wouldn't necessarily have to here. That means that. After all that, what do we have? 1. Not 0. Was it 1?
Yeah.
Yeah. Okay, so that's the first 5 choose 0. That's a 1 there. Do not let me mess up. This says 2x raised to the 5th. Guys, that's 32x to the 5th. 4 raised to the 0 is not exciting. It's also a 1. So is my first term in this expansion 32x to the 5th? Second term. That's 5 choose 1. Oh boy, here goes. 5 choose 1 by formula. 5 factorial over 1 factorial. 5 minus 1 factorial. Guys, let's see, without expanding all together, we got 5 factorial. 1 factorial is easily done as 1. This is what, 4 factorial? The truth? Can I just go ahead and cancel?
Yeah.
Yeah.
Like, go ahead and cancel 4 factorial into 5 factorial, leaving me 5. This is 5. Now you could go ahead and expand that out if you wish. 2x raised to the 4th, I think it's a 4 there, it is. That's gonna be 16x to the 4th, is it?
Yes.
Times 4. Yes or no? Okay, let me add that. Guys, got the first term finished. The second term, it's right, that even blue right above it. 5 times 16 is what, 80? 80 times 4 is what, 320? I did that quickly. 320x to the 4th. So the first 2 terms of this crazy thing, there should be 6 terms. First 2 is 32x to the 5th and 320x to the 4th. If we don't have a mistake. Wow. Binomial theorem. Guys, we had a good course there, don't we know? Now, that's all I had. How about you guys? Any questions? Any questions on this last one? By the way, now if you got desperate, but I wouldn't accept it, you can do it for a check. You could do this through Pascal's triangle that we talked about on Monday. You do it for a little check. Guys, anything else? Looks like something easy test. Why not? There's good range you put on there. It should be hard. Mr. Park, I may have to work with you to create this test. Looks too easy.
I'm gonna have that U is greater than A thing. I think that's what it was. It was like a few different formulas.
It's on the trig, and where they ask you, I guess I
I
forgot what
think it was before the trig.
Like,
It was like, I think it was, I don't remember before this, but it was like, I think one would say, U is greater than or less than A. You don't know what I'm talking about? Oh heck, I don't remember what it's called.
okay, no, I doubt that would be on the test.
Okay.
Okay. Guys, anything else? We feel pretty good after this? I think we did a pretty good review, didn't we? Okay. Now, I did not touch a rational function, guys, a graph. You got to look at that yourself. Those asymptotes and could be a, what was it, oblique asymptote. Could be a horizontal asymptote. And you got vertical asymptotes to worry about. And what? Holes on graphs, crossover points. Remember doing all that? Could have one of those. Nothing to ask about? So guys, we did in about an hour and a half. Okay. Good luck on your test. And you know it starts at 3:30.